Hello friends and Vande Mataram. Today here we gonna be learning about law of chemical combinations in the lesson of atoms and molecules. So introduction of atoms and molecules and chemical combinations are one and the same. So we are starting with the law of chemical combinations and introduction of atoms. Okay. Now in the next video we will be discussing about Dalton's atomic theory. Now here let's learn about law of chemical combinations. So actually these are laws of chemical combinations because there are two laws of chemical combinations. The first one is the law of conservation of mass. And the second one is law proportion. So there are actually two laws of chemical combinations. That is the first one, law of conservation of mass, and the second one is law of constant proportion. So here in the first part of the video we will be learning about law of conservation of mass, and in the second part of the video we will be learning about law of constant proportions. And these two parts of videos are in one video. You're seeing that. So let's begin. So guys, let's begin with the video with the first law, that is law of conservation of mass. So what is law of conservation of mass? Now when we move forward we will also learn about law of conservation of energy, law of conservation of linear momentum and many things. So what are these law of conservation? So these law tells us that any mass, any energy or any momentum will not be created and nor be destroyed. Okay, so here what this law of conservation of mass states us? It states us that the element or mass, okay, mainly mass will not be created nor be destroyed in the chemical reaction. Okay, so when the chemical reaction takes place, when we take a look of chemical combinations, the mass will be same. Okay, it will not be created nor be destroyed in the chemical reactions. So this is what law of conservation of mass. It's very simple. But the next one, that is law of conservation of mass. So law of conservation of mass simply states as that the mass will not be created and not be destroyed in the chemical reactions. Okay, so this mass can be referred to atoms, elements, mixtures, anything else, but it's stating us mass will not be created nor be destroyed. Okay, so the first one is clear. So let's move to the second. So what is the second law? Second law is about law of constant proportion. So what do you mean by law of constant proportion? Okay, so law of constant proportion. So we all know that what is proportion and also ratio, and we all know that what is constant. So what these mathematical statements are related to chemistry here is what when Lavoisier took a look of chemical combinations, he saw that every element had its own ratio, okay, and every chemical combination had a constant proportion of their masses. Okay, so let me take best example, that is H2O. So what does H2 has its constant proportion, it has its constant proportion of 1:8. Okay, and what are its masses? That are hydrogen and oxygen. Am I right? So if one is hydrogen, then oxygen is 8 here. Okay, so if I have 9 grams, or I can take 18 grams of water, how much hydrogen will I find in it and how much oxygen? So it's very simple. I will have 2 grams of hydrogen and 16 grams of oxygen in it, because the constant ratio for that is constant. Okay, so however you take the water, you may take 1000 liters, 2000 liters, but the quantity of masses in it will be at ratio 1:8. Okay, so this was something called law of constant proportion. So this is the second law of chemical combinations. We also have saw about the first law of chemical combination, that was the law of conservation of mass. And in the coming videos we will be also seeing about law of constant proportion and also about the law of conservation of linear momentum. So let's have an example of this. So another example which is given in the textbook, that is about ammonia. So nitrogen and hydrogen are in the ratio 14:3. Okay, so the constant proportion for that is 14:3. So you may take 27 grams, you may take 1000 grams, you may take 100 kilograms, or how big the mass could be, but the masses of ammonia will be divided as per the constant proportion. Okay, so this will never change, and if this increases or decreases, the ammonia will be not formed. So this is how chemical combinations work, and chemical reactions and chemical combinations are formed. Okay, so compounds, I can also say how compounds are formed with the help of elements and masses, how they combine, how they react, and how the masses are not created and not be destroyed, and how there are some constant proportions perspective to their masses. So they are formed according to the proportions of the masses, and if it's increasing or decreasing, the compound will be not formed. Okay, so it will be something else. So this is how the constant proportion and the laws of chemical combinations work. So in the next video we will be learning about Dalton's atomic theory. So wait for that. Subscribe our channel to get all those notifications and press the bell icon also. So share this, like this video, and comment below for whatever video you need. Thank you. Jai Hind.